In the ever-changing world of business, an organization's success depends on constantly meeting new challenges and adapting to the marketplace. I'm Greg Gumbel. From e-commerce to investing, business strategies to human resources, join me as we take a closer look inside the workings of the modern global economy. Welcome to the Economic Report. Whether it's cars, computers, or mobile devices, technology plays an integral part in our everyday lives. Take a look at this next story.
The most important aspect of any material is its internal structure. Studying the microstructure of a material provides information linking its composition and processing to its properties and performance. Take, for example, a cake. Studying its internal porous structure can lead to an optimized baking process and a tastier treat for all. Or consider ice crystals and snow. By examining their structure, scientists can form mathematical models to predict avalanches and potentially save lives. Breakthroughs in CT scan technology are affording scientists the ability to take three-dimensional images of the microstructure of objects without having to cut the object open to look inside. The technique, known as X-ray computer microtomography or micro-CT scanning, is being used in research and product development across many fields.
Well, micro-CT scanning is comparable to the medical CT scanner or CAT scanner, where one is able to look inside the human body without having to cut it, so in a non-invasive, non-destructive way. We also look into objects and look at the internal microstructure. And we see details which are 1 million times smaller than in a medical CT scanner.
At the forefront of this advanced technology, Antwerp, Belgium-based SkyScan has been developing micro-CT scanners for more than a decade. One of the company's main founders, Alexander Sasov, was the first scientist worldwide to publish results on micro-CT technology.
In 1996, we developed first prototype of standalone micro-CT scanner. In 1997, SkyScan was founded to commercialize this technology. And since then, we developed a number of different scanners for different application areas.
SkyScan provides the highest possible resolution in CT scanning through state-of-the-art hardware and software programs.
Micro-CT use X-ray to transmit through the object. Object placed between X-ray source and camera, and cone beam from the pointer X-ray source magnify image of the object to the camera. Micro-CT turns object by small steps, very often less than 1 degree, to get number of angular views.
At the end of scanning, a series of 2D X-ray images of the object are transmitted to a computer. From the projected X-ray images, a powerful workstation can calculate a number of virtual slices through the object non-destructively. By stacking these slices, the workstation creates a 3D image of the internal microstructure of the object.
Once the images are imported into the computer, you can scroll through the cross-sections. You can select a region of interest to analyze it. Or you can measure 3D morphometric parameters. You even can create a virtual model to fly through the object.
This quantitative analysis can have vast implications.
We developed an in vivo micro-CT for small animal imaging. With this scan, we can look to the bone and see what is the effect of specific medication to the bone structure. Or another application is to see what is the effect on lungs of tobacco use.
We have a broad number of applications in material science. For instance, we scan parts of an engine of a car. Food, like ice creams, where you want to look at the foamy structure of ice cream. Breakfast cereals, when you put them into milk, you want to have them crispy for some time, and this is related to the structure. Paper towel, which you use in the kitchen, the structure is related to its behavior. Snow, where the structure is actually related to the risk of having avalanches.
Whether we realize it or not, we rely on this microstructure analysis as it relates to the performance and properties of numerous objects that surround us.